I got asked a very good question today, I thought, about tangents and parabolas and where they intersect. So the question said, find the equation of the straight line or lines which pass through the point 1, -2 and are tangent to the parabola with the equation y equals x squared. So for those people that have done calculus, this seems like a very calculus question, but this was in a year 11 course where we haven't learned calculus yet. So what we need to do is we need to think about how we can do it without calculus. So let's just get a feel for what's going on with the question. We've basically got this parabola y equals x squared, it's our most basic parabola. And then I've got this black line here, which is just a linear line, y equals mx plus c, and I can change the c value, as you can see, and I can change the m value. So I can change c and m to be whatever I like. And basically you can see that there would be somewhere along here where it's going to go through 1, 2, maybe somewhere around there, but it also has to be tangent to the graph. So, you can almost just using these sliders here, you can sort of almost estimate where one of your solutions will be because it has to go through that point. And our job is to find where the gradient values and the C values such that we get an answer. You can probably already see there's going to be two solutions. There's going to be this black line here, but if I do a radical shift and make m negative, you can probably see that I could probably get one over here as well. Ooh, you get the idea, hopefully. If I move it there, you can sort of see if I get the numbers right, I'd be able to tangent somewhere else over here. So this is why the question has, and it's sort of implying that there might be two answers. Okay, so let's dive into it. It's going to be a bit tricky, so let's have a think. The first thing we're going to do is we're going to say where these lines are equal to each other is where x squared equals mx plus c. Now we don't know what m is and we don't know what c is. So all we can say for now is that x squared equals mx plus c. If we rearrange that, we get x squared minus mx minus c equals 0, just moving the stuff on the right-hand side to the left-hand side. And now that's a quadratic. And we know if it's a tangent, then the solution only touches it once. And when we start thinking about touching it once, we're thinking about the discriminant. So we must know that the discriminant of this thing must equal 0. So the discriminant will be negative m squared minus 4 times 1 times negative c, which, if you simplify, gives you m squared plus 4c equals 0. Now, that's not solvable for m or c because there's an m and a c in it. So what we need is another key piece of information. So we're just going to pause on that part for now, but we know that the discriminant is equal to m squared plus 4c, and we need that to equal 0. The other piece of information we're going to need to realize is that, we've got our line y equals mx plus c. We know that when y is -2, m is 1. So in our linear line, we know that -2 equals m times 1 plus c. And just rewriting this, we get m plus c equals -2. So what we can actually do is we can rewrite this in terms of c. So c is equal to -m minus 2. And hopefully you can see where this is going. We're going to take this c value, -m minus 2, and we're going to substitute it into m squared plus 4c equals 0. So you get something like this, literally taking a c value, -m minus 2, and putting it in here. So m squared plus 4 times -m minus 2 equals 0. Expanding that out and, collecting any like terms and whatnot, we're going to get m squared minus 4m minus 8 equals 0. Okay, now we're thinking, how can we solve this? So how can we find the gradient, the correct gradient? Remember, we need to find the correct steepness. There's going to be one about here, and there's going to be one, when it sort of tangents and goes through there as well. There's going to be another gradient value. So there's going to be two gradient values that work. So what we can do is we can actually just use the quadratic formula. So if we solve that, we're going to get 4 plus or minus -4 squared minus 4 times 1 times -8 all over 2 times a, so 2 times 1. Okay, this simplifies to 4 plus or minus the square root of 48 on 2. The square root of 48 is 4 root 3. And then we take a 4 out as a factor of the numerator. So we get 4 times 1 plus or minus root 3. 4 cancels in the numerator and the denominator. So we get 2 plus or minus 2 root 3 as both our solutions for m. And just so we can get a feel for it, it's around -1.46 and 5.46. That's what those numbers are approximately equal to. Okay, So that's the hard, well, that's if you followed it this far, you're doing well because that's probably the tricky part. Once you know the M value, you can find the C value and you can therefore find the equations of the line. So we know that the gradient, let's just take the positive one for now. So y equals 2 plus 2 root 3 times x plus c. Just taking the positive component. You can do the negative component later if we like. And then we also know that it has to go through the point 1, negative 2. So when y is negative 2, x is 1. So we get negative 2 equals 2 plus 2 root 3 times 1 plus c. Solving for c, so just rearranging that for c, take away 2 and then take away minus 2 root 3. We get minus 4 minus 2 root 3, which is approximately negative 7.46. Okay, now what a mouthful. So this is our final answer. So our gradient is 2 plus 2 root 3 times x minus 4 minus 2 root 3. This whole thing is our c value, minus 4 minus 2 root 3. And that's the equation. So what we can do is we can actually set our sliders equal to those values. So we know the m value is 2 plus 2 root 3, which is 5.46. I'll get as close as I can. 5.46 is about there to the closest decimal. And then, oh no, sorry, that's C. We need m to be 5.46. So that's about there. We need C to be approximately negative 7.46. It's about there. So you can see it's looking pretty good. It goes through that point there. And if we look up here, it looks like it just touches it here. I think we can do even better though. We're going to go one step further. And we're going to make it exact. So what we can do, if I click on here and then go settings, I need my C value to be exactly, let me check. What was it? My C value needs to be exactly minus 4 minus 2 root 3. Minus 4 minus 2 times the square root of 3. Okay, so that's exactly right now. And then my M value needed to be 2 plus 2 root 3. Okay, so now it's actually exact. Those sliders are exactly where I need them to be. So if I click intersect, I can click this green line and the red line and the black line, and I get 1 point of intersection, which is exactly what we wanted. Okay. If you've gotten this far, you've done well. You can obviously think the other solution for M is going to be 2 minus 2 root 3. So you're going to be, doing this last step, but you're going to use the gradient is 2 minus 2 root 3 this time. You get a different C value, and then that would tell us where the other point is. It's got a tangent, it's got to make a tangent. You can sort of play around with it a bit. It's got to go through there and it's got a tangent just. So, we're somewhere in that ballpark, whatever these numbers are. We get pretty close. You get the idea, hopefully. You need to make the numbers exact such that it works perfectly. Maybe we can get close. Yeah, it's somewhere around there. Okay, but you can work that out on your own. So good question. Challenging one to do without calculus, because with calculus this would be a lot easier, but good to be able to stretch your understanding as far as you can before you learn the new skills, I suppose. Good luck.